let's bust the globe. This picture was taken from the Bastiment's Peak. We are just going to discuss the L.O.B.O. photograph because it is the clearest peak, even though it is not the farthest. The Bastiment's, where the photo was taken, has a top elevation of 9,452 feet. The target peak, L.O.B.O., has a top elevation of 9,150 feet and was 243 miles away from the photographer. At an observation height of 9,452 feet, the globe accepted target hidden height is 10,240 feet. Remember, L.O.B.O. only has an elevation of 9,150 feet. That means that all of the peak should be hidden behind the alleged curvature with 1,000 feet to spare. Here is L.O.B.O. from a closer observation point. Here's a closer look at the long-distance photograph. As you can see, it appears as though all of L.O.B.O. is visible. This photograph is impossible under the globe model.
California. You're about to see the world with new eyes. The veil of haze and fog will be lifted, and you will behold the flat earth like never before. But before that, let me show you how I got here, because it's been quite a journey. Back in January 2016, I clicked on my first Flat Earth YouTube video out of curiosity, and I was hooked. I bought a camera and headed to the beach. This was my first photo that got me thinking. I took pictures of distant islands from Santa Barbara and started doing calculations based on known reference points to see if they appear at the correct elevation. I've done a lot of imaging of oil rigs to see if the curvature of the earth hides them at all. Lots of thinking over 2 years. I began to realize I need to see through fog and haze because at the coast it's usually hazy most of the time. I got into infrared photography. This is a 720 nanometer filter for my DSLR camera, and I was impressed. It seemed to work better than visible. I even headed out to different places to explore the flat earth. This was Salton Sea in California. The water was very calm and I could see very far. Then I went up north on a trip and I was in Idaho. And this is Lake Pandoray. And I was able to see a boat way in the distance. Slowly I began to realize that there is something to this flat earth movement. This is Lake Tahoe here, 18 miles across the water. And I could see the casinos. This was highly fascinating, but the next experiment really got me thinking. I was flying from Buffalo, New York to Chicago early in the morning, and there was glare over Lake Erie, and I could see way in the distance. I was testing out the notion that the horizon rises to eye level, and using a app on my phone that takes advantage of the inclinometers, I placed the crosshairs down at about negative 3.3 degrees, which is where the horizon should be from that high up in the air. Yet I could clearly see the lake. this was really something else. I really got hooked on this flat earth. I set out to prove to myself that it's refraction. Refraction must be what is causing this flat earth phenomena. I started studying the mirage over water, and the closer I looked at it, the more disturbed and perplexed I got. Light seemed to be bending upwards, not downwards. Initially, I thought the reflection is off the surface, but the surface is rough. It can be off the surface. Then I started reading different papers and I realized there's a evaporative boundary layer. I began to realize that the shallower the observational angle is to the surface, the more prone it is to refraction in the evaporative boundary layer. Beyond a certain critical angle, there is a lot of bending of the light rays. That's why when the flat earth researcher looks out in the distance, the angle becomes shallower. Based on this new insight, I decided I need to sight objects over land and really tall objects like mountains, so the angle is somewhat steeper and I can minimize atmospheric refraction. And to see as far as possible, I started using infrared, which can pierce the fog and the haze. Now have a look at these videos.
What a gorgeous day in Malibu. Let's see what we can see here. There's a light right there. There's a light. There's Santa Monica.
Now have a look at the invisible world.
It's a gorgeous day. I'm gonna go walking on this trail right here.
Here we go. I'm in position and I'm pointing the way towards LA. And there you have it. That's LA with the San Gorgonio Mountains in the distance, over 100 miles away. Incredible. But wait, there is more. Look at that. That in the distance is the ghostly figure of Mount San Jacinto by Palm Springs, over 117 miles away. I'm panning to the right and there's another mountain peak that's visible. There you go. That's the LAX control tower to the right. Just incredible. That peak is over 70 miles away. This is just incredible. Look at the difference infrared can make. It can reveal the unseen. The perfect tool for researching the flat earth. Let's have a look at the map to see what we saw. There's 3 lines there and those are the peaks that we were looking at. Very far away, incredibly far. But I wasn't pleased with the resolution, so I embarked on another project, a high-resolution imaging project. I bought a Celestron spotting scope and a monochrome astronomy camera, and I put an infrared filter in front of it, an 850 nanometer infrared filter, and it worked pretty good. Have a look at this. Look how I can zoom in on an area. That area in infrared was 3000 by 2000 pixels, high resolution, and I could zoom in. This was the island visible from Santa Barbara. but soon I went to Malibu again. Have a look. Wow, just look at that. Wow, behold your flat earth, folks. Let that sink in. If this doesn't move you, perhaps math will move you. In the next slide I'm going to show a scale. I finally had the resolution I needed, and I could create a scale based on one of the buildings in the foreground. So based on the building you see in the foreground 12 miles away, I now had the resolution I needed to see the floors, different floors, and I averaged a few of them together and I assumed about a 12-foot separation between the floors, and based on that I created the scale in milliradian. And wouldn't you know it, that mountain not only is visible when it shouldn't, but it's showing up at the correct angular elevation. Simply amazing. Now, if the Earth was curved, we shouldn't see Mount San Jacinto, even though it is 10,600 feet high. The shoreline and the hills on the other side of the bay should be hiding it in entirety. Now, if we compare this to the flat surface model, look how simple it is, and it is accurate. We calculate the correct elevation of 17 milliradians. Simply incredible. Now I'm gonna leave you with these images. Just ponder this, folks. This is incredible. That's all I can say. Incredible. Behold your flat earth, folks. Just incredible. This picture was taken from even farther away. I went to Point Dumais, 122 to the peak. The peaks to the right, 125, and even farther away. Just incredible. The ghostly image of distant mountains, bearing a silent witness that the earth is flat.
Alright, here's my setup. As you can see, not far off of the water. It's actually frozen there. Maybe it's about 32 degrees, maybe 31 degrees outside right now. My wife will have a spotlight that direction at Eagle Park. Put this, you can see it's standing on the ice right there. There's really no extra inches to be involved here. And the height, about 30.5 inches. Okay, ground itself is about 28 degrees. 27 degrees. Let's go over the water. Well, you can see it's gonna 24 degrees. There's the access point. As you can see, there's a smokestack over there that's attached to a ground moving at 1,000 miles per hour. Filming that way towards Eagle Park in Saratoga Springs, Utah. Alright, so I'm south of the Linden Marina. Access point. Access point is over there. Be filming towards Eagle Park in Saratoga Springs. Just want to show you. I just thought this was fascinating, is how you can see the reflections on the water from this distance. Now that's probably about 7.5 miles at least away, maybe even more. But you can definitely see the reflection on the water when you would, even a centimeter of curvature would stop that from happening. I believe that right there is defining the globe model.
I'm just under the trees right now.
Okay. You under the trees? Are you spinning around your light at all? Is there any light like it near you, or? Wait a second. Turn it off. I found you. Turn it on. Yeah, you're in between lights. Okay, I found you. Can you go down the lower now? The peninsula. I definitely see you again. This is awesome.
Yeah, there's ice out here, Ben.
Yeah, it's cold.
It's really far out ice. See it for you?
Yeah, I see it perfectly.
You're shining on the
I don't see it now.
No.
Okay, are you out? Are you out to the water's edge yet?
Yeah, I'm out to the, well, not to the end of the peninsula.
Well, you don't need to go all the way. I see you, just until you get to a water's edge, because you know, get as much distance as.
You want to be at the water's edge?
Yeah.
Okay.
And all you have to do is now lower it. You're at where's it at? Like shoulder, chest high, or?
It's on the ice. Do you see it?
I just see glowing. But yeah, I can see a reflection in the water sometimes. Shine it on the water a bit.
Is this shining on the ice?
I don't see it.
It wasn't shining at you.
Now I see a reflection. Okay. Before it dies or anything, can you lower it as far as you can go? Just tell me, kind of speak out and tell me where it's at.
Okay, do you see it?
Yes.
Okay. Do you still see it?
Yes.
Do you still see it?
Yeah.
You still see it?
Yeah.
It is on the ice right now. The edge of the light is on the ice.
Holy crud. Alright, that's pretty much flat Earth. I don't see it.
It's on.
Okay, I'm gonna keep it on a second. I'm gonna zoom out. Be sure to grab your GPS coordinates right where we're doing this.
Okay.
So you have it on the...
It is on the ice. You still see it?
Yeah, I do.
So I'll turn it off. It's off?
Yep.
It's on.
Okay, I'm gonna zoom out again. Oh, you know what I'm gonna do? I'm gonna...
See about grabbing those coordinates.
Okay, also... I just finished a flat earth test at the Utah lake. Just confirmed again that this lake is flat. I'm just waiting for my wife to come pick me up. It's freezing out here. Maybe 22 degrees or so. I'm frozen. I filmed her over there at Eagle Park in Saratoga Springs. She brought the light all the way to the ice and laid it on the ice. She recorded her GPS coordinates. I recorded my GPS coordinates. We should have exact measurements. Took some temperatures of the water, but the water's freezing. It's below freezing, maybe 25 degrees. I don't know what to say to you. If this lake is flat, then the entire Earth has to be flat. That's the only logical conclusion. All it takes now is a little bit of bravery to come to that realization. The Earth is flat. It's shocking. We have been controlled in ways that we can't believe. They control our minds, our finances, our health, our education, our sciences.
Alright, so now to get started, let's look at our positions on the water. Now, Mark was at Owen Beach at Point Defiance Park, and you'll see his laser fade in on the horizon. And I was positioned at Saltwater State Park in Des Moines, Washington. Now, while we're here, let's take into account what these two land masses would look like from my position facing towards Mark's position southwest. Alright, so the distance between these 2 points is 10.3 miles. Mark's going to say in a little bit that he's about 7 feet above sea level. That gives us a target hidden height of 33.2 feet.
I'm going back on again.
Alright, yeah, bring it back on. Alright, yep. Alright, let me see. You're about dead on. Just a second.
Boom, boom, boom. Alright, bring it to the right. Bring it to the right. Little bit. Alright, stop right there. Bring it back a little bit. Ah, shoot. Hold on. Wait. Stay right there. Stay right there. Yeah, let me hit record. Ah, shoot. We're out of focus. Still see it, though. Look, we're out of focus and we still got a picture on the laser. Now, I zoomed in, it kind of looked like one of those stars. Alright, hold on. Let me try to get this thing focused again. But yeah, I see you, man. Here, point it back to the left a little bit.
Your left?
Yeah. Yep. Bring it back just a hair. Boom, right there. That's perfect. Stay right there. Stay right there. Honestly, what's your elevation right now? You're in the water right now?
I'm checking the heights right now.
Awesome. Alright,
Let's see. I would say 7 feet.
7 feet off the water.
about 7 feet off the water. Okay.
At this point, I'm anticipating that someone suffering from cognitive dissonance is going to say, no, he was more than 7 feet above sea level. Okay, so let's say 8.5. Now, where's the other 30 feet of curvature? Then somebody else is going to say, no, he's higher than 8.5 feet. Okay, let's try 10. So where's the other 27 feet of curvature? Yeah, stop it.
So here, I'm gonna lean down a little bit. It's like the tide's coming in. So hold on. Let me back this thing up a little bit. The water's coming in. Yeah. Give me a few seconds. Back it up just a little. Then I'm going to adjust my tripod to get the.
Yeah, this battery takes a lot of power to run that laser.
All right, yeah. Turn it off for a few seconds, but try to keep that position. I'm lower this time. So I got the camera like at about 3 feet above the water, somewhat. You know, got the tripod down low. So let's see what you got now, man. Let's see if I can find you.
I hope there's enough power in this. It takes quite a bit. Here it goes.
Okay. All right, hold on. Oh, yeah. Hold up. Wait. Stay right there. Right there. Let me get you. All right. So, okay. So, hold on, dude. You see it right here. All right, folks. Boom. There's a laser right there. All right. My tripod is nice and low. You see me? Boom. We're 10 miles away. I can see that laser. Mark, about how high are you above the water?
Right at about 7 feet.
Right at about 7 feet, and you're like kind of pointing downward toward the toward my position. Then that's cool. All right, yeah. So yeah, everybody can see that I'm about 3 feet above the water, and yeah, we can see the laser just fine. Can't we, people? Can we see the laser just fine from 10 miles away? over all this flat water. Don't we see? Isn't that what we're seeing right now, people? 10 miles away. Look, you can see the laser. Dude, I can see the laser with my naked eye right now. Everybody can see it off in the distance. I'm not even looking into the camera right now. We can all see the laser together right now. 10 miles away, dude. Here, let's get lower. I'm gonna put the phone down here. I'm gonna put the phone down here on the ground. And we can still see the laser. Yeah? Huh? Everybody still see it? We're on the ground right now. 10 miles away. Huh? Do we need to get into the water? Let's get into the water a little bit. Huh? How about that? Oh, look, people. Hold on. We're in the flipping water, and you can still see the laser. Huh? Huh? Checkmate. Checkmate. That's game. That's game. That's game. Is it not? That's game, dude. Yo, Mark. Hey, I think we got enough, man. I think we can wrap this one up.
I know. We've all been taught that we live on a globe since we were children. But look at that globe and recognize that the blue areas on that globe represent bodies of water, namely oceans. But as I always say, the Earth's surface is 71% water. Bodies of water do not curve, therefore the Earth is flat. Consider what you see in reality and ask yourself what makes the most sense. Water doesn't mysteriously start to curve downward after 10 miles.
Hello YouTube, faithful subscribers, whether you're boosting my ego with positive comments or you're keeping me on my toes with some intelligent trolling, you're all appreciated. Despite the fact that I've already proved flat out that curvature of the Earth can't be measured, and that is not due to any kind of atmospheric refraction, light bending. And despite the fact that I've devised a definitive curvature test using multiple reference points to prove that the Earth is flat, I often hear that it can't be proven either way, whether the Earth is round or flat. So I'm going to take the flatness test a few steps further and go into a bit more detail to prove once and for all that we're living on a plane. I'm going to stick to using photos of the Kaikoura Ranges in the South Island of New Zealand, taken from Wellington's south coast. This gives us a pretty decent range in terms of point-to-point length, as well as a decent range in heights of peaks that we can use. I've been out there a few times taking panoramas, as the spot's just breathtaking, especially at sunset. On the day I was out taking these shots, the conditions were just about perfect. The further away the mountains are from the camera, the lighter they are. That's because there's more atmosphere between us and the further mountains, so they get kind of washed out. Pretty obvious, but this photo demonstrates it nicely. I'm going to pick out a few prominent peaks and color code them for convenience. And now go to Google Earth and find them. And a few weeks later I've found them. It's pretty hard work, but I'm confident that I have found the right ones. But please don't take my word for it, check for yourself. Everything you need is right here. Once again, I'm going to enter the heights of the peaks and the distance from the camera into a graph. Now I go back to the photo and make a horizontal line at the height of each peak, color coded of course. Since the furthest mountain away is also the tallest, I can just cut it at that point, and where that line meets each other point gives us an extrapolation to a 2D view to count for perspective. So hopefully it'll match up to the lines on the photo again. Let's have a look. And once again, pretty much perfect. I'm guessing refraction's not playing much of a part here. I don't think we get a whole lot over the Cook Strait, judging by my experimentation. And what anomalies you can see there, I'm willing to bet would be a result of Google Earth's measurements. We can't expect Google to have accurate data for every nook and cranny in the Kiwi bush. That's some pretty full-on wilderness out there. Now I'm going to do the curvature calculations for each of those peaks and input that into a graph to do a comparison. Let's see how it looks. As I suspected, it's all over the show. Not only does it not match, but some of the lines have crossed over. Any of you ball lovers out there care to explain that to me? I didn't think so. If we get these scales matched up, we can get a rough idea of how it would look if there were any curvature. I'll leave you with that. I'd have to say, curvature thoroughly busted. Once again. Thanks for watching.
Today is a wonderful day for truth, and the truth that we have today is that the earth is flat, and there is no argument, no debate with this, and I'll show you exactly what I mean. This by Joshua Nowicki. This photo is the photo of debate for flat earthers. It is approximately 80 miles from the Chicago skylines. And the news, if you remember, reportedly made the people believe you should never be able to see this in a million years. But because the atmosphere that day was so magnificent, we could magically see this illusion. So let me show you something that no one can argue. So here we are, beyond horizons, home of the current distant sight world record. How about, instead of 80 miles, how about the current world record of distance landscape photography? This is not even a flat earth site. They are taking photography, and they have no idea that they just debunked the globe entirely. The silhouette of Bar des Écrins, 4,102 meters in the middle left of the image. From Pic de Fenestres, 2,820 meters at 440 kilometers. Before the sunrise, and other pictures more left, other summits a little more far away. This was dated July 16, 2016. It tells you the lens that it used. If you wanted to, you could grab a telescope to see even further than 440 kilometers. View the Écrins in the broad daylight in mid-February thanks to exceptional weather conditions. With help also of a polarizing filter was a huge satisfaction after previous attempts, sometimes collectively as well as individually. I had already portrayed in January of 2015 the Écrins Mountains, but with a very faint result. Now this is something that flat earthers always describe to the globe earthers. You can see across to another country if the weather conditions were right. And the flat earthers were absolutely correct about this. Last July, from a more distant peak than on previous occasions, in April there was also success and good weather forecast. It made a great success of visibility. The Bar des Écrins relatively clearly manifested backlight of a sun in close position below the horizon. To his left, other peaks of the Alps also were to be seen. Refractive, favorable circumstances allowed to view some other peaks, even that more distant than the Bar des Écrins. Peak Espard, 443 kilometers, is what has given us this time, brand new, a new world record distance of photographed landscapes of our planet. And they're still calling it a planet even though they just proved it was a flat Earth. Some pictures and illustrations. The picture of the current world record illustrated. Here we are, and they have it all mapped out for you. They can see from one peak to another peak. 443 kilometers equals out to 275 miles. 275 miles. That is over 3 times of what Joshua Nowicki did. On good weather conditions, you can see 26 miles further than the ISS. The International Space Station is not this far away. Debunk this. Go for it. I dare you. They have it all mapped out and calculated just for you. Look it up, do what you will with it, but don't make excuses. Map of sight illustrating the overwhelming distances of this world record. Forget about it all. If you can see further than the ISS across to another freaking mountain 275 miles from you, do the math to it. How far should these mountains be under the curve of the Earth? You can also have a look at an interactive view of this simulation here. We are sure that other records will come soon. I bet there will be. In the Pyrenees, the options are almost finished, but any attempt to increase the distance is still possible if atmospheric conditions are especially favorable, refractive, exceptional transparency. We're on that. By the other hand, also, maybe next arises from another continent, from another mountain range of our planet. We think it's really probable. And the number one question that globe earthers always ask, well, if the Earth was flat, how come we can't see from the United States to France? Technically, we absolutely can. The globe is dead.
So I'm in the airport. I just took a flight from Atlanta to Toronto, and I specifically picked the window seat because I knew I'd get a chance to see a sunrise. As you can see, I'm looking very touristy with my P900, but what I recorded was 100% proof that the sun is not 93 million miles away, so check it out. So here's the video I took. As you can see, the sun is about to start rising and it's not even past the horizon. You can see the horizon in the background, and the sun is going to start rising through that thick layer of clouds right there. Now, if the sun is 93 million miles away, it would be rising at the horizon, not in the middle of the clouds right there. So I was at about 34,000 feet when I was recording this with my P900, and I don't see how that is possible if the sun is 93 million miles away. So how is this possible on even a flat Earth? Well,
It is plain to see, if you can see the sun behind cloud cover on a sunny day, that the sun is not a flaming fireball 93 million miles away. It's simply a focal image created by light rays entering through a concave lens where they focus to a single point, which is the sun. That is what's happening here. The light is entering through the dome, and you can see it's creating a sun on the inside. Okay. Now, light rays, the light which was created on day 1, enters through the firmament, which was created on day 2, through the atmosphere, which was created on day 3 when all the plants were created, and it creates the focal image, which is what we call the sun, as you can see right here, angling downward, which produces what we experience every day with the sun, just like this. So once again, this is where I was, heading from Atlanta to Toronto, looking east at the sunrise, and this is me wondering if anybody else in the plane saw what I just did.